Hello and welcome to another tutorial. So this is the second part in the series on building the hybrid goal-oriented action planning system. So if you are looking for the starting point for this project, in the description below you will find 3 links. You will find a link to the copy of the code as it was at the very start of this project, as in this start of this video. You'll also find a link to the code as it was at the end of the video. And the final thing will be a link to a full sort of downloadable package that you can use via the Unity Package Manager of this project. So those links are available there. You'll also see time codes there for different stages throughout the video. So the reason I'm mentioning all of that and that this is a big series of videos is so today I'm going to be focusing on building up the state machine side of things. There will be a little bit more visual stuff to actually see this time, but again, it's still going to be fairly heavily code focused. And because we're enforcing fairly clean interfaces, it is going to be a bit on the lengthier side, and it is going to be more focused on that the architecture and getting that solid. So that's something where if you're wanting to jump to a later stage, things like that, then by all means do that. You've got the various links will be down there for you being able to do that. So let's dive on in. So where we left things last time, we had gotten set up a basics for our debugger system. We had also gotten set up some fundamentals for our Blackboard system, a few different things like that we'd essentially gotten up and running. So I said that this time I want to focus on the state machine system. That is the case. So the state machine system is going to be something that is heavily used by the most of the actions actually. So the actions, I'm going to set them up using finite state machines. And so I wanted to have a system that was going to be nice and reliable for this. And so what I have done in terms of architecting this is the state machines, I've tried to avoid using mono behaviors for anything, because eventually with all of this, I want to be able to have it be configurable in the inspector. So let's dive on in and start getting this set up. Now, you will notice at times I am going to be referring to the set of stuff I already have built. Again, that's because there's a lot of stuff that I've put together, and it's going to make it a lot easier for me making sure I actually implement the correct thing. So we're going to create the state machine system here. Now I'm going to give that its own folder. I'm going to also with that set up a specific assembly definition for it. Like that. Now I'm going to define a root namespace for it. And I also want to make sure that it has access to this common core that I've been working on. So I can apply that. So that's good. So we've got that sort of essential stuff. And then there's a couple of initial classes I want to actually create. So to begin with, we're going to have our various interfaces. So we're going to have our actual one for a state machine state. So I'm following similar process that I did with the game debugger, where I want to actually have a mix of interfaces and concrete classes, and most things work by passing around the interfaces. So I'm going to set up our scripts folder, move that into there. So the reason for doing the interfaces is it just keeps things a lot cleaner, and it means that allows me to have a bit of separation between things. So this is going to be the setup for our state. We're also going to create one for our transitions. So this will B for moving between those. So there's not too much we need to do for setting these up. These are defining really just sort of the core structure of how these are going to work. So we just make the same modification to both of these so that it's clear that it's an interface. Now, if you're wondering about in terms of with the naming convention, we already in C# interfaces generally will have a prefix of I, so I'm just making sure I'm rigorously sticking to that so it's very clear that something is an interface. So, okay, let's take a look at what we sort of need as essential stuff here. So, our main thing for a transition is it's going to need to return a result. Now, this is something where, for the moment, I am using an enum for this, but it is a thing where I could conceivably just use a bool for it. The reason I have, at least for now, stuck with having this be an enum is I could see that there could be a scenario where I want to differentiate between this has succeeded and it shouldn't transition, or this has succeeded and it should transition, or this has failed. So there could be, I haven't run into a case where I've needed a third scenario yet, but it's something where I could absolutely see that we might need that for transitions. So I've tried to make sure that that's supported. So, okay, there's really only one function needed for the transition, and that is we have our transition, and I'll make that clear that that's a transition result. So our transition result, and that we have an evaluate function. And so it's evaluating for a transition from this current state. So we have our current state, and then we have a blackboard. And this is from our common core. And this is Blackboard that uses the fast name. So as I mentioned last time, the Blackboard is kind of the bit of unifying technology for all of our setups with stuff. So that's why the transitions are getting that. It's generally our central point for storing and retrieving any information. So, okay, that was actually incorrectly put in state. So I'm going to migrate that over to transition. I'll do the same thing with this. Strictly speaking, I could put them all in the one file, but I think better to have them split up. So, okay, now we can go to the actual state one. That does also mean we need to, it's already got using Common Core. Excellent. So our state here, well, we've got our debugger, so we're going to start making sure we've got proper support for debugging in here. So we're going to, and this is a thing you can do, you can say that an interface must also implement another interface. That is actually a supported thing. Now, our states. States could be in a range of different statuses, and it's kind of important for us to keep track of this. So this is something where I do make more use of these different types of states. So state status. So, okay, it could be uninitialized. So in uninitialized, we've not actually gone and done any setup for it. We might have created it, but there hasn't been anything further. That state could be running, because a state might need to run over multiple frames, multiple seconds. State machines in particular, it's not unusual for them to run for a long duration. So it could be running, it could be failed, or it could be finished. So there's a few different scenarios of sort of the state that it could be in. What I'm going to also then do is we have an interface for being able to get the status. Now you will see I do a bit of a mix of how I'm sort of working with properties and everything in the States. There is going to be a bit of a cleanup that I will do at a later stage for this. For now, I want to focus on getting things up and running. So, okay, we want to be able to retrieve the status of something. That makes sense. I want to be able to add a transition to a state. And the way I want that to work, the reason I'm having it return a state interface when you go and add a transition is to make it easy to essentially support being able to chain adding lots of transitions in one line to the one state. So add transition, it will just actually return itself. It won't return a different state. It's just going to be returning itself. But it just allows that syntax if people want to use it. It's not going to enforce it, but it does make it a little bit cleaner in some cases. So when we add a transition, we need to provide a transition. And we also need to say, well, what state is that going to? Because a transition is always going to have to go to some other state. Now, when we get to working with the actions, one of the things that's going to be there is, a lot of cases, most states, if they fail, should always go to the same thing. And so that can mean there ends up being a lot of duplicated code for handling that. So I'm actually going to add in a support for adding default transitions. And these will be a state. So one for finished and one for a failed state. This will just allow me to keep that state machine set up a lot cleaner and a lot neater. So I've tried to really structure this from a point of view of making it that you have to write as little code as possible and also making it as quick and easy to sort of iterate and get them set up. And eventually, I do want to have a graphical interface for this. That will not be part of this initial series. That is a later series once I've got this up and running. But it is something that I've tried to keep in mind with setting these up. When we are working with the states, we're also going to need an evaluate for the transitions, because a state is going to need to decide, okay, should I actually make a transition? So that is going to have a blackboard passed into it, just because a state might want to be looking up information from that. I hope if I spelt it correctly. And then the result from that. So this is something where I could have it return the state, or I could have it pass it as an out parameter. The reason I've gone for having it as an out parameter is it gives me the option later, if I need, to also be returning additional information, which might be something that I end up doing. So our next state, like that. So, okay, that's good so far. There's also going to be some common functionality that states need to actually support. So they're going to need to be able to be entered. So there'll be an on enter that will take in the blackboard. So we know that we've entered a particular state. There will also be, and I can just actually duplicate these because they're going to be pretty similar. We'll have an on tick and then on exit. Now, exit is actually going to be a void because we're not going to actually ever be really sort of caring about the status there. If we're exiting a state, it's because we have chosen to exit it. So we don't really need that status information because the choice based upon whether it was failed or finished or running, that choice has actually already happened. So we can skip doing that selection. So on tick, I'm also going to include the delta time in this. Now, the reason for that is because this is not going to be on a mono behavior. It's being ticked externally. And it's quite common that you might want to do stuff that messes with delta time. You might want to run things at a faster rate or a slower rate. So anything where I'm doing a manual tick like this, I try and make sure that the time is being passed in. That way then you're in control of what that time actually advances. So that's good. That's our key sort of setup for our elements there in terms of the actual sort of transitions and the state. Now, with the state machine itself, if we go and set that up, so this is something where, this is one where I kind of was of two minds of whether to, like with the debugger, set up an interface for it. In the end, I decided to go for not doing that. And the reason for that is that with the debugger, I could absolutely see there being a lot of use cases where you might want to swap out that back end of the debugger with your own logic, your own different way of working with things. Whereas with the state machine one, I didn't feel like that was as common. And I also wanted to have the AIs be able to have a reliable pattern that they're actually working on. So that's why for the state machine itself, it's actually going to just be a concrete class. Now, it won't be a mono behavior, but it will implement my iDebuggable. So now we can start to get things set up with this. So the way this is going to be organized, it's going to have a list of our states. So this is going to be keeping track of all of the states that have been registered. We're going to keep track of our current state, which will default that to null. Strictly speaking, don't need to, but having come from doing a lot of C++ these days, it's just easier for me to make sure I always properly initialize things. Because if I forget in C++, it usually goes poorly. Then I want my blackboard, and this will be our linked blackboard. Now that will initially be null. That's something that will actually go and link that up as part of our setup process. Now, iDebuggable is going to be getting grumpy at us because there's things that we haven't implemented. So we can do this. Now, properties, we need to have an implementation for that. So this is just actually going to give back state machine as the name. The gather debug data, we will get to that in a moment. But first I want to set up the other sort of common bits of logic that we're going to need for this. So, okay, there is going to be binding to a blackboard. This will happen as part of the initialization. So we have our blackboard, and in Blackboard. Now this is something where there might end up later on be other things that we bind to, but for now, that's really the main thing. So that's good. We're going to have an add state function. So we would have our ISM state, and we add state. Now this is going to be like that, and then all we will do is states, and we add that, and then we return what we have added. So we're not doing a deep copy or anything like of that. That's intentional, but we do return it again so that if you're wanting to chain add transitions onto the this, you're able to do that. So okay, we've got adding of the state. We've got our support for adding the default transitions. because those default transitions, we set up that function on the actual state interface, but we don't want to invoke it manually on every individual state. What we want to do is we want to actually do that through going and setting up just something on the actual state machine instance. So we'll have ISM state in finished state, and a similar one for in failed state. And all we will do is for each loop through our states. Now, if for whatever reason the state happened to be our in finished or happened to be in failed, we skip it, just because kind of doesn't really make sense for us to add a state to link back to itself, at least in this case. There are specific use cases we'll see where we actually do want the state potentially to loop back on itself, but for this kind of thing with default transitions, I want to actually avoid doing that. So otherwise, what I can do, add default transitions in finished and in failed. So that's good. That will run through and link those up. Now, our state machine could be really handy to be able to reset it, because some actions should actually cycle through the state machine continuously. So we're going to just have a function here, reset, and that will actually be really straightforward. We just set our current state to null. Now we could, with this, do some specific checking of, okay, well, if we're in the current state and that's not null, then we could force an exit from it. So what we could say is current state on exit. Then we need to provide in our blackboard like that. So that makes the reset a little bit safer if we're currently in a state. And I could check if the state is not null and the status is running. Because really, if it's failed, then we shouldn't run on exit because it will have already likely gone through that logic. If it is finished, we also shouldn't do that because these default transitions, they'll have run and handled the cleanup. So unless it's running, running means it's actively doing something, so we want to make sure it properly exits. So that's why we're going to do that logic there. So okay, let's reset. That's straightforward. Well, this is a mono behavior, so we're going to have tick, and we need our delta time. Now, intentionally, and you'll notice this, whenever I'm doing things that are manually updated, I call it tick rather than update. That's to actually make it very clearly distinct so that it doesn't get confused between the two. So there is a very specific intentional reason for that. So, okay, when we're ticking, well, what if our current state's null? So if we have no current state, so if current state is equal to null, then, okay, we want to try and see if we can actually select a state. Now I'm going to change this to, it'll return a ESM tick result, which we haven't actually set this up yet. But this is going to, again, be one that initially will only have 2 ones in this, and it may be one that we never find we need to add more, but it was, again, one of those ones where I felt like it might be useful to have support for other ones later. So, okay, when we tick, if we have no current state, then, well, okay, what if there's no states present? Because if there's no present, we can't really do anything. So if states count is 0, then we're just going to return that we failed. because there is nothing at all that we can do. Otherwise, set the initial state. So in this case, oops, current state is going to be state 0. So that's good, we've selected one. Then, now there is a possibility here that that could be null. If the very first state there is null, then I think we should just go and fail out. So if current state is null at this point, we return failed. Now this could be a thing where we set up different levels of errors, stuff like of that, to indicate what's happening. Otherwise, we know we've got a valid state. So what we can do is we can enter that. So we on enter, linked blackboard. So, okay, if we get to the other side of this if statement, we know a couple of things. One, we know we definitely have a valid state. Two, we know that that state has been correctly told to enter. So we're actually able to tick that state. So now that we know we've definitely got a current state, we can actually perform ticking of that. So we can on tick, and then we can provide our linked blackboard and our delta time. Now, we're relying on the status internally of the states being updated and them using transitions for handling what should actually happen next. So what we will do is check transitions next. And this is going to have our next state, which will default to null. So we take our current state, we evaluate the transitions, we give it again the blackboard and our next state, like that. So now there's a few things that could sort of happen here. One of the key things is, okay, well, what if our next state is valid? If our next state is valid, well then we can tell our current state to exit. And again, we give it the blackboard. We can update our current state. Now that works, and then we tell it to enter this new one. Oops, on enter, and our linked blackboard like that. So I'm very intentionally not making this fail out or skip anything if the next state is the current state. So I do want to validly allow a state to transition back to itself. And the idea is going to be that evaluate transitions only actually populates this when there is a transition to happen. If it decides, no, I'm not actually switching states, then this comes back as null. So anytime this is populated, that means we need to transition. So transition required. So that looks good. And then all we can do down here is return that we are running. So pretty straightforward in terms of the general logic for this so far. We'll get to some of the actual concrete logic for the specific states very shortly. The final thing I do want to do though is set up this gather debug data. So I want to start making sure these are populated for things. Now that we've got the debugger, let's make use of it. So we're going to add a section header. That's just going to be our debug display name. Now, I could do this without using these strings that allow us to evaluate stuff. The reason I have done it this way is it may be something where we do want to look at further customizing the styling, the color of this. So I just wanted to keep that option open there. It's a slight performance impact doing this more complicated process, but it just is a reminder of, okay, do I need to add in further things in future? Then, if we've got a current state that is valid, then what I will do is push indent like that to current state, gather debug data, and then pop the indent like that. Then that's good, that will only output the current state then. But what if we did want to actually output all of them? So what I could do is change this around a little bit. State in states. Now, how that would then look is, if we go like that, while in is selected, and we want to check if state is equal to current state. And then we just change that like that. So just give us a way of, if we do want to have all of the information for all of the states output, we can. So we can see the full state machine there in the debug display. We're just then not, sort of constrained by what else we're seeing. So that looks good. So, okay. Got a couple of other bits we want to really get sort of set up and running with this now, but we're in a position where we can actually start to create our essential states. And the really important one to begin with is actually our base state, because that holds a lot of the logic for working with transitions. So we're going to start with that one first. So let's start getting the base logic for one of these states up and running. And we'll get our core state happening. So we're going to have a states folder. So off of the interface, we will end up with a SM state base. So that's going to be kind of one of the core ones that we actually have. I'm going to have, branching off of that, an SM state. And the idea is this one will be something where if you just want to, you've already got a particular function and you just want to wrap it in a state, that you can do that. So we'll have an SM state function. We're going to also have a SM state parallel. So the idea behind this is to allow us to have some cases of states where we want to run multiple things in parallel. So a good example of that is an AI chasing. The actual location we're needing to move towards, we might be wanting to update that, and we might also then be wanting to continually refreshing the move logic. So there's usefulness in being able to actually have ones running in parallel. And a fairly common one is a wait for delay. So just a simple sort of wait so that we can have a state that actually will sit there for a little bit. So let's get these up and running. So for all of these things, like our wait for time, those are based off of our state base. We'll clear out all of the internals for now. Same with function, so all of those get cleared out. We'll come back to those once we have our base state working. Now our base state is not going to be coming off of mono behavior, but it will implement our ISM state. Now that immediately gets grumpy at us because there's a whole bunch of things we need to implement. So we go and run those. That gets all set up. So, okay, we've got lots of different things here to populate and to make work. So let's start to get these individual things up and running. So what I'm going to do for the debug display name is this is actually going to have a get and a protected set. Not audio settings, just a protected set. Autocomplete getting a little too aggressive there. So, okay, that's good. We'll have the display name, we'll be able to override that. we want to keep track of our transitions here. And what I'm going to do is just have a little wrapper for our transition entry. And actually that doesn't need to be public, but it can be protected. So this is just going to have a public ISM state, and then it will also have, and I'll put it above it because it will have a transition like that. So this is just essentially a mapping of this transition will go to this state. I could use a map for it, but I decided that because of the way we're working with it, we might have a lot of extra logic there. I think it's going to be cleaner and neater to have it that we potentially could have duplicate transitions there. So I think this is a better setup for it. So make sure our naming convention matches. And then we need to keep track of our status. So our status, this is our current status, and that is going to be our uninitialized. And I will also make that protected as well. So that's good. So, okay, adding the default transitions, that's something we'll come back to. Firstly, I want to set up a constructor. So our state base, I want to support one that takes in a custom name, but allow that to be null. And then what I will do is our debug display name. Well, we're going to check our string is null or empty. If it is, then we're going to do a get type and use the name for that. Otherwise, we'll use the custom name. So this was something where initially I didn't support this, but I found that with reusing the same state a lot for the same action, it's actually really, really helpful to be able to customize that name. So now that's a default thing that's supported, is customizing that name. So get status, that's an easy one. We return current status. So that is one we could change over to being a property. So we haven't done that currently, but we could do that, of have that be an actual property. If we went to the ISM state, we don't have it as that currently. How that would look if we did change it over to that is if we look at IDebuggable, that actually is what it would initially look like. So we might look at changing this over to that sort of setup. So we give this a current status and make it like that. And then what that would mean is in state base, well, we don't override get status anymore. We wouldn't actually have that function. So what we would then do for the state, because this is going to be grumpy at us, because we haven't implemented that current status one, we would have public status, current status, and we're going to do get detected set like that. And then we're going to initially set that to uninitialized. So that's good. That might mean that we need to make some modifications to the state machine instance if it's grumpy. Yep. So we've got our current status like that. So it just makes it a little bit cleaner in terms of setup. Okay, we've got that implemented, so that's good. With this, we've got a couple of other things that we want to get sort of set up. So, okay, adding a transition, pretty straightforward. That's going to go and say transitions, add, and a new transition entry. And then we can provide our individual sections for that. So the actual transition and the state. So that's good. And we return this. So that's all we need for adding the transitions. Evaluating the transitions, we will take a look at next. So this, because a particular state might want to customize and override this behavior, what I'm actually going to have is also a protected virtual, and it's going to look very similar to this, except it will be evaluate transitions internal. And then here, what I will do is I will run that evaluate transitions internal with that. That is a void. So that's good. Now, in terms of what the actual internal logic here does is, okay, well, our next state, default it to null. We loop through our transitions. So a transition entry in transitions. So if that transition entry dot transition, and then we evaluate it. And what we're evaluating is our current state, which is this, and our blackboard. Now, if that comes back as valid, then we set our out next state to our transition. Actually, that should be entry. We'll set it to entry dot state and return immediately. So we're looking for a transition. As soon as we find something valid, we just switch directly to that. So it won't weigh up between the different transitions. That's not anything that we're wanting it to be doing. So that's good. We've got that side going. Let's start to take a look then at some of our other ones here, like onEnter. So our onEnter, all of these ones, these are things that we might want to override them in the child classes. So I'm going to have a protected abstract, and we'll have, again, our state status, and we'll have an onEnter internal. We pass in the blackboard, like of that. So all that the onEnter here is going to do is go and say, okay, well, our current status is equal to onEnter internal, like that, and we return the current status. So that's all that we need that to actually do. Now we can see this is getting grumpy at us. So the reason for that is we have to actually say up here that this is abstract, like that. So that's good. That works for onEnter. The onExit and things like of that are actually going to be very similar. onExit doesn't have an actual return, so it just ends up being onExit internal, but we'll do the exact same logic. So we do an exit internal, pass in the blackboard. onTick, again, fairly similar. The main difference here is we only actually tick if the current status is that we are running. So for the current status to be running, that means that the onEnter has actually successfully happened. So if we are running, then we're going to have a onTick internal. So what we'll do is current status is onTick internal. That'll get the blackboard, that'll get the delta time, like that. And again, we return the current status. So it's going to look pretty similar to our onEnter internal. Main difference is slight name change. Main difference is a slight name change, and we also pass in the delta time. So that's our enter, exit, all of those sort of core functions happening. That's we haven't implemented the gather debug data yet, and we haven't implemented the adding of default transitions, but that's those key initial bits going. So now there's a couple of other sort of things that we can get up and running. The default transition one is probably a big one. So we want to know if finished is handled. So by default, we'll assume that it's not. We also want to know if failed is handled. Because what we'll do is, well, if finished is not handled, then we'll add a transition, and we'll add that transition. So transition. Now this will be an actual, we haven't actually set this up yet. So I'll put this in as a placeholder because we don't have that particular transition yet, but these will fill in. What we'll be then checking also here is we'll be going through and we'll have our transition, well, our entry in our transitions, and then we'll be wanting to check if this thing actually handles both of those. So this is a to-do as well until we get those transitions set up. So we've got those to-dos marked. This will also, if we reach a point where finished is handled and failed is handled, then we just actually return. There's nothing for us to do. So we'll come back to that once we set up the transitions. So that's in a good spot. We've got our gathering of debug data, which we haven't actually implemented anything for yet. So this is going to be pretty straightforward. We're going to add a text line. So this is going to be our debug display name. So we'll have that. And then because we want to be able to allow states to override and substitute in their own data, I'm going to have a virtual void, and this will be a gather debug data internal. And we'll just have nothing that it's doing, so child states can override that. And we'll just run gather debug data internal, our debugger, and if we are selected. So that's pretty much the core for our base state. We want to get some stuff set up so that we can actually get a few more things up and running. We do have obviously a lot of things grumpy at us because we don't have some of these basic states set up. So we're going to get those implemented now. So let's look at wait for time. So it's grumpy because we haven't implemented these things. That's fine. So this state is going to be given a min time, and it's going to have a max time, and it's going to keep track of the time remaining. So we want a constructor for it. So this is going to be the general structure for all of these. They'll have a constructor. Now that's a reasonable sort of set of stuff there. I'm going to fix the naming to match the conventions that I've been following. Shouldn't have time remaining there, but it should have an in custom name, which we default to null. That I will pass to the actual base class. And then these get updated like that. Time remaining, I still don't do anything with it there. What I will do is with the time remaining, okay, well, when we enter, we're going to say time remaining is a random range like that. Now, if our time remaining is greater than 0, so if time remaining is greater than 0, then we're running. Otherwise, we're already finished. So that's it for on enter internal. On exit, doesn't need to do anything. The on tick, well, if the time remaining is greater than 0, then I want to reduce it by the delta time. And then this exact same logic here can be brought over. So that's all there is to the wait for time state. Now I can improve the debug a little bit by having a protected override and of our gather debug data internal. So we run the parent one, and then what I will do is push the indent. I will add a text line that all the text line is going to be is a time remaining seconds, like that. And we just remember to pop the indent. So it just gives us a cleaner interface for the debugging. So that's all there is for the wait for duration one. Function one, so this was our one that allows us to wrap a block of code. So this one's going to be even easier one, but this one is going to take a few different things. So this is going to make use of system.func, and this is going to have a blackboard fast name, and the out result is going to be a status. So this is going to be the on enter internal function. So you might be starting to see what the pattern will be for this. This will return on enter internal function with the blackboard. We'll do the exact same thing for the tick function. The difference there is that it will take in the blackboard and a float. So this is an on tick internal function. So it will be return like that. That's not the right one. We want it down in here. And then we provide our delta time like that. And then our final one is going to be for exit. Now with the exit one, what we can do is exit doesn't really need to provide a status. So that's one where we could do a system.action instead, because that's not going to give any return values. So that will take a blackboard with fast name, and then yes, this is our on exit internal function, and we run that here with our blackboard. So this gives us something we can easily wrap around existing code. As with the others, this does need a constructor. So we have our constructor. Now with this, we want to have all of these passed in. So it ends up being a little bit messy. I usually just end up copying and pasting the stuff like that, just to make it easier to get everything set. And these will be our in versions of those, like that. And we remember, we also have in custom name. We want to make sure we support that for everything. For something like the function one, I would say that's even more important that we actually do that, just so that we have to provide the name there. And that is one where we could remove the default parameter if we wanted to mandate it. So then now we have our on enter that, our on tick internal, and our on exit. And that's it for the state function one. That's all it needs to do. There's nothing further, nothing sort of fancy to that. So then we have our parallel one. So we're going to get this up and running. So again, we let it sort of set up all of the different ones. Now this is going to have a list of states. These are going to be the child states. And intentionally, I am not newing that. I don't want that to actually have anything that it can be doing to start with. We will have a state parallel, and we will allow it to be given that initial set of states. Just rename that. And again, our custom name. That. So that's good. So, okay, well, on enter, if we have no child states, so if child states is null, or if child states.count is 0, we are just going to return failed, because there is nothing that we can validly do in that case. The same thing is true for if we are ticking. There is nothing that we can actually do, or that we should even try and do in that case. And the same thing is true for exit. Difference is with exit that we don't actually return a value. So, okay, that's good. Okay, so let's look at setting up the actual sort of key parts of this logic. So for when we're ticking, let's set up the essentials for that. So child in child states. And because we're going to use this in a few places, I'm going to rip this straight off and add it to our on exit and our on tick. Now, for our on exit, it's actually really easy. Our on exit just needs to go and say, okay, well, let's just do child on exit, and we provide the blackboard. So nothing much to that one. On enter is a bit more involved because there's a lot of things that could happen in on enter. When we enter a particular child state, it might fail. That is a possibility that could actually happen there. So, okay, when we go and do this, we're going to keep track of our result. So our result from going child on enter and providing the blackboard. So if that result is a failure, we're actually going to fail out immediately. So if it failed, we're done. So that's good. If, however, it succeeded or it kept running, if everything finished, we actually kind of want to know that. So we want to keep track of here if all are finished, and if they are, we'll assume by default they are. So in this case, if the result is that it is running, then all finished is false. Then down here, if all are finished, whoops, then we return saying that we're finished, otherwise we're running. So the idea behind this is any one single failure will cause this on enter to fail, but as long as something has finished, but something else is running, we'll just actually keep saying that we're running. So that's a very intentional thing there with that. Now tick is going to be a little bit similar. So because with tick, we're going to say, okay, well, again, all finished. And we actually can steal this exact same return because it's applicable to this. So we'd get the result again. So our result child, and we go tick, provide the blackboard and the delta time. So again, if we failed, that is an immediate failing out of the actual state. Otherwise, if the result is not equal to running, or actually we could check if the result is not equal to finished, then all finished goes to false. So that just gives us a better setup with, this will run these states in parallel. If one finishes, then it can stay finished, that's all good. If one has further logic to do, then it can indicate that and the parallel one will keep running. So that's good. I also want to override the internal sort of setup for the debug display. So we run the base. We again do similar to what we did with the other one where we push the indent and we will pop the indent afterwards. But what I will do is for each child, we want to let the children actually add debug data in as well. So they can gather debug data and output like of that. So that's a couple of core essential states. You can see those errors are now gone. Now we do need to get our transition logic set up. That's something where we haven't created that yet. So we're going to create a folder for our transitions. And then what I will do is a similar process. We're going to have a transition base. We'll have a transition that is based on a function. So there'll be a transition function. We want to also have with this something where it's actually checking a particular state status. So we'll have an SM transition state status. And final one, we might just want to have something where it always essentially falls through. So I'll have an SM transition always. So this is going to be quite similar to what we were doing here with our other ones. So I'm going to close a bunch of these things because we don't need them anymore. And we're going to get these set up. So our transition base doesn't actually have to do a lot. It's actually pretty minimal what it's going to need to do. And so these are actually pretty quick to set up. And that's very intentional. We want them to be nice and easy to be able to get up and running. Visual Studio's decided it needed to relaunch. Cool. And have an extensive think about it and mess with line endings because, of course. So this is not based off of mono behavior. That's, again, very intentional. But it is this ISM transition. We get rid of all of that logic. This is also another one that is abstract. Now what we'll do is tell it to implement the interface. So, okay, we know we need this evaluate function. So we're going to have a protected abstract one that has to be implemented. And this is our transition result. Evaluate internal. And it's going to take all of this exact stuff. So nothing fancy in terms of what it's doing there. And unsurprisingly, this then ends up being our evaluate internal like that. So pretty straightforward. So that's all we really need for our base transition. Then if we look at our ones, and did it actually load the always one? So for our transition always, it's obviously not going to have starter update. This is going to be our SM transition base, and then that's going to have this one single function, which for this one, unsurprisingly, it's always valid. The idea is just if we want to have a forced transition, so nothing much to that one. The function one, it's a little bit more involved, but not by much. Because again, it's only really got a single function that it needs to actually support. So there's going to be a system func that takes in a state that then also has a blackboard. That's our fast name, and that gives back a transition result. So this is our evaluate transition function. We'll have a constructor. Again, this is not going to be a surprise in terms of what this looks like. We have this as a parameter to it, like that. The actual logic of this, straightforward. And then the only thing we need to do is implement this method, which again ends up being really straightforward. So if our evaluate transition function is null, then what we will say is that it's invalid. Otherwise, we'll actually run that function and provide it with our current state and the blackboard. And we just return the result we get back from that. So again, this is something that allows us to easily create a wrapper around existing logic that we've got. So we don't always have to implement a full state if we don't actually need to. And then our final one here is checking a state status. So this one, again, transition base, like all of the others. This is going to keep track of a state status, and this will be the required status. We have our constructor, like this, and this will take in our required status. And then all we do for the evaluate here is, okay, well, if our current state and the status is equal to the required status, then the transition is valid. Otherwise, the transition is invalid. That's all we actually need for it. So it's a pretty straightforward sort of setup for it. So that's ideal. What this also means is this is how we will do, remember those default transitions? So if we actually go back to where we were doing the setting up of the default transitions and we had some to-dos here. So what this would look like is add transition, and we would create a new SM transition state status. If the status is finished, well, actually this is, yeah, for the finished handler, then we provide the finished state. So that's all it needs to do. We can thin that down. Same thing is true for, that actually gets done like that. So for the failed one, we dispatch to the failed state and we check for that. So that's pretty straightforward. The to-do here, you might be not surprised. What we actually will do is a transition state status, state test. That is going to be our transition, or our entry dot transition as that particular one. If it is not null, so if it's valid, then what I want to check is, well, okay, finished handled should be true if that state test handles a particular state. In this case, if it handles the finished status. The failed one will be very similar, and that's failed, like that. So what I can do, and the reason I set this up as a function is because conceivably we might want to support in the future multiple states. That's the only reason I have gone for doing it this particular way. So this is our status to check. So for now, all this will do is return if required status is equal to that. But later on, if we had different flags there for the statuses, or we wanted to support a transition that handles multiple ones, like a kind of kitchen sink one, then we could easily do that. So that's actually the core of our state machine system. Now, there's a lot of bits that we've implemented there, and I do actually want to allow us to see some basic stuff happening, because this is something where it's great to have all of this, but it would be even better if we could see this code working. So I'm going to create a folder for a test scene. And what this test scene is going to have in it, we're just going to create a new basic scene. And this is just going to be our state machine demo scene. Now I'm going to load this state, or load this one up in parallel with the village one. The reason is I want to really easily be able to bring over the gameplay debugger and also bring over the event system so that the UI actually works. And then I get rid of the village one without saving it. Now I'm going to change this so that the background is a solid color, like that, make it a fairly dark color. This will allow us to easily sort of test the gameplay debugger as well. So I'm going to create a little empty game object here, state machine, and I'm going to create a script here, and this is just going to be essentially our test wrapper. So test wrapper. So we'll bring that over onto the state machine. Now I'll actually have state machine 1 and state machine 2, just so we're also then testing that this is actually working. So far so good. Let's look at what we want to put in this test wrapper. Now it's going to be pretty minimal. It is going to be still a mono behavior, but I'm going to make it a debuggable object. So this is going to you have common, actually, that's right, I need to bring in using common core. So have I debuggable object. So that's going to create some things we need to actually set up. So far so good. That means if we let that create the interfaces, well, our display name, I'm just going to go with game object name. So it just links directly to that. I'm going to set up our state machine instance here. So this is going to be our linked state machine, and we'll new that. Now in the debugger interface, all I need to do is go, well, linked state machine, gather debug data in debugger, and if it's selected. So that's good. Start, I can actually create it. In update, I'm going to tick the state machine. So we'll tick and time.delta time. So that's good. We need to be able to easily register our sources. So that's something where what I want to be able to do is a game debugger. Now, I would have to normally go instance register source, but I'm going to set up another interface for this. So what I'm going to do is I'm going to have public static void add source, and it's going to have the same thing, or takes in a debuggable object, and if instance is null, we just return. Otherwise, we do instance register source, like that. And we're going to do the exact same thing for the unregister, just so we've got these easy static interfaces, but our actual calling code doesn't need to worry about making sure everything is safe. So what this then lets us do is we can go, well, game debugger, and we can go add source, this, in our on destroy, we would go game debugger, remove source, this. So that's good. Now let's actually create our state machine and look at how that actually looks. So we're going to have our state, and this is going to be linked state machine, add state. We'll create a SM state wait for time, and we'll make that between 2 and 5. And we'll call this wait, like that. Now I'm actually going to create a few ones here. 1, 2, and 3. We'll give these their custom names, like that. Then I want to add the transitions. So, okay, well, state 1, add a transition. So transition is going to be our state status. And if it's finished, then we go to state 2. Unsurprisingly, state 2 will then go to state 3. And then I'm going to add in default transitions. So with the default transitions, all it's going to do if things fail is just actually go back to state 1. So essentially, it'll restart itself. So that's good. Added all the default transitions. We've registered it as a source. That probably means we can just test this and see how it works. And we should see our gameplay debugger information appearing. Now, we might find that we have a whole bunch of bugs. Let's find out. We'll run it. So we can see state machine 1 and 2 are running there. We can see state machine 2 is the one we've actively got selected, which is why it's bolded. We can go to state machine 1. That's now bolded. So we can see when we're running this, it does give us the output for the full state machine, even for the not selected one. And I'm inclined to say that what we should do is, if this thing is not selected, then we actually don't output it. That's one option that we could have. So this is something where this is a little bit down to, personal sort of taste of how you want it to be functioning. It could get, a little bit too messy if we're listing everything. So I'm going to say, if it is not selected, then we just return. So what that will do, if we take a look now, is state machine 2 is there. We can see everything. If we want to tick over, then what we can do is that, and it properly shows us state machine 1. So with that, we've now got our sort of fairly flexible state machine system working. We've got it integrated with our debugger. So again, similar to the previous video, it's a lot of code, a lot of setting up of stuff. And the reason is, while it is a lot of front-loaded work before we actually see anything, we do then get to a point where it's going to be a lot easier in future. And again, this is something where if you are wanting to jump ahead, if you're watching these videos as they're coming out, they will be coming out sort of back to back each week. So you won't need to be waiting more than a week for the actual next part. Or if you're watching it further in the future, then the next part will already be out and you'll be able to be seeing that linked. So if you do want to jump ahead, you'll be able to do that. Or if you just want to jump to the specific AI package, you can do that as well, because there is that link in the description below. So next time, what we're going to be doing is starting to set up our actual planner, starting to set up the brain of the system, and getting those sort of core bits needed for our goals and actions up and running, so that we can then start to implement more of our actual behaviors. So that's the plan for next time. Thanks, folks. Hope you found the video interesting and helpful. So if you are looking for any of the associated code for the project, there are 3 links down in the description. The first is the code as it was at the start of this video. The second is the code as it was at the end of this video. And the final link is going to be to the actual completed package that you can use with the Unity Package Manager. So if you're wanting to grab the codes at any different point, those are all available there. If you've got any questions, chuck those in a comment below. And if you are looking for other ways to support the channel, then I do have a Patreon, and there is also a link to that in the description as well. But until next time,